Thank you all for joining us today. As mentioned, we're going to be talking about reinforcement learning at scale. There are three of us, and I'm going to set the stage. I'm going to talk a little bit about perhaps not the topic you're most excited about from this talk, but the overarching context and what we see more often than not from different game companies, particularly as it relates to the business analytics and AI, but then how that applies to what y'all are more interested in, which Duncan will continue on the reinforcement learning, on some use cases that we're seeing there, on applications. He'll go through a demo that shows how this is working within Unreal Engine and what we've done to scale out reinforcement learning with Unreal. And then finally, Kyra will dig deep into running Ray at scale with Databricks. So I'm not going to talk about and say that word again. Duncan will talk a little bit about how to do it with us, and then Kyra will go deep into the actual execution side of it. That sound good? Awesome, great. The number one question that we get asked is, what do data companies do with, or game companies do with data? And this is a list, big list, obviously, of things across the board that we see globally. As you can see, a lot of this fits into the more business side of things. Not too surprising, as data was born in the marketing groups of most game companies. And frankly, a lot of game developers never really exit from an analytics perspective the left side of this slide. As you get more advanced, as you start to actually see that you can't watch every single game session, every single play session, and you start to collect more and more telemetry that Duncan will talk about, you start to open up the build better games category. And this is the section I think that y'all are going to be much more interested in today. We've highlighted in green the easier. This is where people begin. The yellow is where people continue. The white is, we'll call it the nice to have list, is the future and the more advanced use cases. The next question, though, that we often are asked is, but this is all, that's games as a service. Single player games don't care about data analytics, right? Like, that doesn't matter. And frankly, in the last week and a half, I've had several game companies say, I'm working on a single player game. Once I release the game, I don't need telemetry anymore, right? I don't need data. The game's released. Well, hopefully your games aren't released and then forgotten about. And I'm not saying that necessarily you're going to go down the cyberpunk route and for 2.5 years be releasing large updates, but understanding how your players play, what they're doing, how they engage with the game itself will help not just from the business side, but as you think about your next title, as you think about how you want to engage with your players going forward. When we look at some of our best stories, when we look at the things that people are doing the most, really it can all be boiled down to, and if you leave nothing from my section in this, personalization matters. Making the game personal to that player will enhance their experience, will have them remember your title more, will have them coming to the next game more often. And each and every single one of these stories is some level of personalization. One of my favorite, though, is Mojang down here, not because necessarily it's Mojang, and yeah, we love Minecraft, but because it shows that small changes can have huge impacts. So several years ago, they released, started to work with recommendation models, and the impact of those recommendation models is unparalleled. And this was just UGC recommendations, relatively simple model, more than doubled engagement with different things within the title, right? This wasn't deep neural networks. You didn't have to get all the way to the very bottom. With just heuristic-based models, you can have a huge impact on what you're doing and the engagement that you have with your players. But every single use case that you saw on that other slide is some level of evolutionary story. And it's going to evolve along different aspects, but at some point you will hit diminishing returns, right? So when do I stop is another question that we're asked often. whether it be, this is more on the recommendation model side of things, whether it be, do I get down here, I stop at statistics or forest the trees? We can't answer that question, right? At some point, the juice is not worth the squeeze, as we would say across the pond. At some point, those diminishing returns just do not make any sense. But that's not the end of the journey. That's just a message that it's time to work on something else, right? And someday you'll get to a point where you've filled out enough of those boxes that you're happy with your MVP or you're slightly detailed, and you'll come back and you'll continue to evolve. That's what we see happen across the globe. That's what we see people doing. The last thing before I pass it over to Duncan is you can't have a talk, you can't have a discussion with a game company without someone asking, well, what about Gen AI? Gen AI is the answer to everything, right? What is the one use case for Gen AI? What's that one thing I should be doing? And fundamentally, we think that's the wrong question. Because Gen AI isn't a destination. It isn't an answer in and of itself. It's just another model. It's just another piece of the puzzle. And so as we think about where Gen AI is applicable, the answer is in almost every single context, to some degree, to some form, Gen AI can help. Particularly when you break it into two big categories. My favorite category, the boring AI. This is the leveraging of generative AI against your own data, against your business problems, against the things that are not creative in nature, that have all sorts of issues in and of themselves, that spurn very challenging conversations that are very exciting, but are also very scary. There is so much value that can be brought in through just that left side of this slide, that this is, if you're going to be thinking about generative AI and how you use that, start here. You're not going to offend anybody. You're going to bring lots of value to the business. Eventually, you will shift over here and you will experiment and you will play with all of these things. Don't get me wrong. And you will find a lot of success, particularly over here in these marketing use cases, because frankly, it's already being done by the people that you're outsourcing marketing creative to. It's what they're doing already. And so as you bring in sourcing of that, as you try to do things like personalized messaging, e.g., let me look at how you play the game, how you engage, the things that you find interesting, and then create one-to-one messages that maybe, instead of generating that marketing creative, maybe it's ensembles, different key art pieces, so that you respect the arts, that you have less issues as it relates to the, we'll call it the six-fingered man in The Princess Bride, if that's not too deep a cut. Let's have less of that. Now, with that, I want to pass it over to Duncan, who's going to go into more detail and give you some real-life examples of how people are doing this today.
Yeah, and I do want to call out, the boring stuff gives the funding for the fun stuff. So it's just the reality of it. And more are researchers in these larger studios that we work with getting pulled out of their labs now, especially with the hype around the generative AI side of the house. They're getting pulled out of the labs more to help different teams come up to speed with different technologies, different things like that. So it may not be the case for everyone, but many of the teams are getting a lot more mixed, or they're being reorganized into areas that they weren't originally in the past. And so when we look at general use cases for things like reinforcement learning, we're kind of like a little focused here in this case is cooperative competitive multi-agents, like training believable opponents or teammates, bots coming in when players disconnect, being able to discover exploits, bugs, glitches, especially with all the testing. So having agents running through levels to see how things are rendering on different drivers and different GPUs, that side of the house, dynamic difficulty. And some of these talks are happening in the previous AI for Games at GDC. You'll hear many of these different research labs at different companies, especially Riot Games. They continue to push the boundaries on the reinforcement learning side. they talk a bit more about this. So I put these up there as there's public research in each of these different areas around reinforcement learning, taking these use cases and bringing those out there. So especially, Wes sitting here in the middle. so, and then when we look at capturing data, so telemetry for all of these different use cases, we run into this case where either studios have different experimental things and they're trying to productionalize or move it a little bit farther along, and they're often lacking in data. And it's really kind of coming back to how you look at capturing data, how you begin to look at, you're trying to model behavior. And so having data around the things they're trying to model, being able to capture even these new agents out there, how do you begin collecting data? And so a lot of this is just like thought-provoking and as you're going throughout these projects. So begin to collect things from online, agents that you're deploying out there. Collect these things from the players that are out there so that you may be able to start trying to do imitation learning, or, like how are players going throughout levels, so you can run an agent through that automatically, for some of the other use cases. So it's really just, you're not only building a system, you need to also think how do you measure, how do you collect for these systems.
We get asked about imitation learning quite a bit, and no one ever has the data, right? Like, it's not something that people are preparing for. So we wanted to call this out because as you do think about this in the future, like online is easier from that perspective because you're doing it right then. You're collecting the data as you are building these models. But if you're going to try and replay so that you can build these agents, just wanted to make sure that that was being thought of.
Yeah. And so we'll have a small section of this is kind of continuing. We worked with Brendan and Epic Games a while back, but Brendan has been leading a team around Unreal Engine's learning agents. So, Unity has their own as well, but many studios often implement their own implementation too. But especially with kind of the rise of Unreal Engine nowadays, we're kind of continuing off of that as it showcases the integration into the game engine itself quite a bit. So part of it is there's a tutorial out there from Epic Games around learning agents, the driving simulator, improving the driving side of it. And then what it kind of covers is the plugin as part of the game. It allows you to train the actual agents, locally inside of the game. And then it replaces some of the standard like rules-based or behavior tree, state machine type work, but it's not a general purpose ML. So some of the use cases, a lot of the use cases that Hunting was talking about earlier, wouldn't be done in this. This is particularly around taking an agent with an action space and training it. So we're kind of talking about today is like, how do we begin to look at, scaling that? So I covered some of this just a second ago, but the learning agents has blueprint friendly implementation. It's highly performant in engine, but that typically works whenever you're looking at a simple driving. When your action space gets much larger, when you're trying to train in multiple complex environments, you need to be able to scale this out much more. So it's kind of a continuation off of Brendan's talk. I think it was last year here. Keep going on. So when you go through the tutorial, it ends up in a setup where in your local IDE of Unreal Engine, you end up with the variety of things that's already built into the game, the build process. But over in Python, you have just a simple train the PPO model type setup with lightweight TensorBoard metrics that are being captured there. And this works for a tutorial. It works for getting the started in it. But in a lot of the cases for the different studios or publishers that we're working with, that's not scalable. It's not, you can't run this on, really large action spaces or complex environments. And especially when you start to try to scale this out to how do I run this, 1,000,000 times or, 1,000 times or whatever your combination of, depending on your complexity is, that doesn't really work. You can't shove enough GPUs in the machines, etc. And so what we started to work with Brendan on this was then how do we take and scale out that type of training? So, it's a combination of using Unreal Engine as more the portal to look at the different trainings that you're doing, but actually push those environments off into, distributed larger systems that can run these complex environments over and over. So the solution that's out there, because we couldn't go through all of it in 40 minutes in detail, but the solution out there takes and implements, the environment using Ray on top of, a platform like Databricks to go through and capture those metrics, to capture those environments, the telemetry off of all of those things, and then you can watch it in real time inside the editor itself. You can look at it as each one of those agents, those cars driving around the track, improve. So they stop like just going off the road and they start staying on the road. And it moves things down to where in a very simple scenario, a car that was running off the road in about 45 minutes locally, depending on your GPU, improves and can stay on the road consistently. But when you can scale that out and you run 20 instances of those, it's in like 3 minutes. So it's a factor of scale at that point.
And like, ooh, yay!
One of them worked.
One of them worked.
It's like, and so while there's a bunch of notebooks there, it really kind of boils down to a single notebook. You're just taking that same Python process with an environment that you've packaged up through the build, from Unreal, and you can toss that out into, the platform like Databricks. But in this case, this is showing, stepping through. It's not a ton of code. A lot of it's just configuration setting up, but you get to the same type of train PPO Python setup with the tutorial itself from Unreal. So you can see configuration of how many nodes, which would then spawn how many instances of that same type of setup. Now, underpinning this is, using Ray, and Kyra will go through a bit more talking about Ray, but you end up getting down to the same kind of bit of code that you would look at inside the tutorial as well. So it's overall a pretty simple setup, but the whole goal is that, scale the experience. So, each one of these agents needs to see, experience over many, many instances. More experience, the faster it can train. The, scaling the experimentation, but also an aspect that isn't typically covered. It's the monitoring and management of this model. It's the monitoring and management of the metrics. How do you see one versus the other? How can you go back and see, the efforts in which you have, been training on? And then how do you scale and, that usage and monitoring from a cost perspective as well? Because inevitably someone's footing the bill. Like I said, it was the boring use cases earlier, but someone's checking that. So when you look at scaling reinforcement learning, when you're taking the research that you guys are doing and moving it into a larger environment, all of these things have been done for a long time in the traditional ML space, this traditional ML frameworks. And so all this setup does is teach you how to merge those two worlds together, in using an environment like Unreal Engine. So,
and we are, like, you're probably thinking the question, so I'll frame it out. We're constantly asked, well, why don't I just do this on my local machine, right? We've got local machines, they have GPUs, I can do it there. And Duncan kind of commented on it earlier. It's really about speed to iteration, right? You can do it locally, but it might take you 3 or 4 days to do it when it's all said and done. And that's just time that you are wasting, that you are waiting for the outcome. By scaling out to a platform, we are one platform, there are many platforms out there. You can go from being able to do one experiment a day or a week or an hour to many hundreds, to many thousands. And that just means that you end up with a better model ultimately, but you do have to have some of the capabilities that Kyra's going to talk about in mind to be able to track and trace and monitor and improve. That, Kyra?
Thank you, everyone. So yes, how do we achieve this scaling? On Databricks, we use for this particular use case Ray, but you can use it for like not only reinforcement learning, but other type of Python applications and advanced AI applications. So Ray is a unified framework for scaling AI and Python applications. So it's built on a distributed runtime that has specialized AI libraries. And it's been designed to support from like custom Python distribution to advanced AI, like the reinforcement learning that we are using here in this demo. And the key benefit of Ray is that it handles the complexity of the distribution of the execution so that you can focus on your algorithm and just let Ray handle the parallelism across the cluster. So that's like the beauty of it. And in the case of the demo, what we were having is 20 parallel simulations running simultaneously while we were training a single shared policy. So, and these 20 parallel simulations were giving the trainer then the whole observations that it needed then to get to a better policy and make that the cars will start showing that they are learning how to drive on the track. Cool. So this is just like a brief intro into what's Ray. So how does it work on Databricks? As Hunting and Duncan were mentioning, the beauty of using it on Databricks is that you have like a one platform where you can have manage your data. Here we have Delta Lake and Spark. So in this particular use case, we were not dealing massive amount of data, but if you have some use cases where you need to prepare your data set or special features, that might be really helpful to have everything in one place where you can access, manage who is accessing it, democratize it as well. Then we have the Ray component where the Ray apps are handling the distribution of the training. And again, if you have a use case where you have to give to Ray the data, you can use Spark, or you can transfer to Ray data as well if needed. And then once you have trained your model, you can serve it using MLflow to a model serving endpoint where you can run real-time inference. And in general, MLflow is really amazing to track all your experiments, all the runs you're trying, all your hyperparameters, so that you can compare runs and see that it is improving. Or maybe in 6 months' time, you want to try something else, and then you can still compare. You are not losing anything that you have done.
Well, I'll add into there too. You're going to iterate over these implementations, these models that are out there. And part of the build process can pick up from your central model repository in which you're constantly iterating and training and tagging these on. So having that way to promote your research, your experimentation in a way that other CI/CD processes can pick up that and leverage it inside the building setup without you, here's my USB, or it's on Google Drive or wherever your artifacts may be.
Exactly.
And I imagine hopefully all of you know, right? MLflow, open source. We have a managed version of it, but it's something you can use regardless of what you're working with.
Yeah, and then the bottom part, Unity catalog, is just what enables you to govern all these artifacts and share them and so forth. So, and yeah, access controls and monitoring as well. So going back to, this is a bit heavy, but going back to the use case for per se, so the learning agent use case. So in general, when we are distributing reinforcement learning, we have 3 main components: the trainer, which is running the algorithm and updating the policy. We have the rollout worker that is executing the current policy in order to collect experience and then feedback to the trainer with that experience and what was the reward of that action. And then we have the environment where the agent is acting. And here we have 4 typical deployment patterns using these 3 components, where the main difference is just where the environment sits. It can either sit on the rollout worker, that's the standard environment, the very simple one. If you have something more advanced, you can have the external environment running, in our case, where we have the game engine running the simulation, but it's still in the Ray cluster. And then for other applications where you have the environment outside geographically in a different place and so on, then you can have your application process outside that is then talking with the Ray cluster. And even further, you can have the same, but then catching the policy as well in order to be more efficient when running the simulations. So just to show some typical patterns for the use case of the learning agents, how to learn to drive is the second one we have here. And maybe I can just like deep dive here. So what happens is that the environment is, you have the simulation, right? You have the track there, and then you have the car, and then what should the car do? So it gets an action from the rollout worker. The rollout worker has a status of the policy, and will get like, okay, you need to turn right or left based on the observation space you have at the moment. The engine, the environment will then do that action, collect what happened and the reward, and then the rollout worker will send it back to the trainer as rollout fragments. And there are fragments because we have several of these rollout workers working in parallel. And then the trainer will aggregate all of this feedback and train the neural networks, change the weights in order to get, hopefully, a better policy that then is propagated back to the rollout workers for the next step, and so forth. And so this is in general how it works with Ray. And all of these together, working with Databricks, will be, so we have the Unreal Engine, where the game components are and so on. Then your game is then packaged in binaries that then are ingested into the platform in a volume, to call it volume. So you have the executable there in Unity Catalog. Then this is used by the game engine to run the simulation. The Ray worker then is getting all the feedback and sending also what actions to do, send it back to the PPO trainer. So here we are using PPO in this use case. And then all of this is happening with the orchestration of workflows. So that's what Duncan was showing before. So using CI/CD, you can have like all the configuration of your training there, and then automatically in a version control way to just like start a training with this configuration. Then those are the asset bundles, the CI/CD bit. The workflow starts, you start the training, the runs. MLflow is tracking everything that is happening. And then once you're ready, you can register your model, or you can also register some checkpoints if you want to. And then download it to the Unreal Engine to run with the new updated version of it. And yeah, as mentioned before, so this is really useful because if you are a team, you can share what's going on. You can build up on it without losing any information. And yeah, give access control as well. This is just very quickly how to trigger. So from the CI/CD, we are triggering a job, and you can see all the parameters that were configured. And it's just to show that this is a very production-ready way to work and build up and don't lose your track of what you're doing. And then here, very quickly, I'm just running up. So MLflow tracking, here is just an example of we ran an experiment on the learning to drive environment. And it was just running more than 25 runs. You can see all the metrics that were logged automatically. I didn't have to do any coding there, so it just automatically running everything. And then you can also like have that data lineage of what's going on, what are the whole parameters that were in that model that was giving that policy that was resulting in these results. And then if we go into detail, you can also have these plots automatically created for you, where for instance here we are analyzing the experience, what was the evolution of the model, and we can see, for instance, that the average return was getting really good after about 1,500 steps. Average reward for the like individual actions was in average getting better and better as well, more or less at the same time. And the episode length just passed from being very short, like it was crashing or getting out of the track, to just like getting into a stable track where it was achieving the goal.
And real quick on this, I mean, especially whenever you move away from your local experimentation on it and you start scaling out, you immediately get that loss of control, that loss of like what's actually happening, um, and whether or not it's looking at all of these, like swapping between environments through like the Unreal Engine or whatever client that you're looking at, being able to look at how far along is this, do we need to let it run, you know twice as long or 3 times as long as local, or this will give you that pulse on when can you go ahead and stop the running and take that latest checkpoint, because as you can see, it flattens out quite a bit. So most of it happens near immediately, and then you're getting to Hunting's analogy earlier, the juice isn't worth the squeeze as you get later on.
Exactly. And this is just another example just to compare, like we saw what is happening and now how it is happening. So just seeing like the quality of the critique, prediction of what will happen, and also the quality of the policy. And you can see also like lots of experimentation at the beginning and then getting stable. So just to show you have all this data that you can easily then just like take and analyze and see what's going on with your model and what is the best cut point and the best run. So in a nutshell, so what we saw in terms of like infrastructure, we recommended, for instance, for this use case, it was like the recommendation was to have like GPU node on the trainer because it is running the neural network training, and then on the workers, it's enough to have CPUs. They are very quick and they are just like running the execution of the current policy and getting the experience. So it's not that massive. And then you can also parallelize easily as well across your cluster. Then start small and scale up is another recommendation, instead of starting with a lot of parallel runs, just like to get to that sweet spot of cost performance, and leverage the whole ecosystem. So for the data, for the MLflow experiment tracking and so forth, and then for the governance and access controls, Unity catalog. And then on MLflow, it's just like little things that help, like run your tagging accordingly, meaningful names so that you know what's going on, tag your parameters so that you can filter them out easily when analyzing the data. Use CI/CD in order to have like all the versioning and the best practices of software engineering. And just leverage Unity catalog for the model governance.
And crazy enough, the naming is very important whenever you have two different systems tracking, the metrics, and you're looking at it from, like an MLflow dashboard type perspective, and then you want to actually look at a checkpoint, and you want to actually like what was happening or recreate that from the engine side and actually watch that simulation happening, making sure you maintain some relationship that you can easily like look between the different, lists of thousands of things happening, helps.
This is just obviously an introduction. We have, as you said, published a lot of the code, all the code to this online, so you can easily find that. If you don't locate it, you can always get in touch, let us know. All the things we've talked about today began with a studio saying, we want to do a thing. We have a problem, we want to explore it. And so if you have one, either that we talked about or we didn't talk about, and we can help, we're here to help. We're a group of gamers that care deeply about this industry, and we want to do whatever we can to help you succeed. So thank you for everything that y'all do. It's a hard industry to be in, and we really, really appreciate the dedication to play.
Thank you.